The MCAS loves to give you at least one question about where current will actually flow in a parallel circuit, and a parallel circuit with a bunch of switches in it. So let's just look at switches for a minute. What's that thing there sitting right there? Is that an open or a closed switch? That's a closed switch, isn't it? Current can flow through it, which makes this one an open switch. Current cannot flow through that one, correct? So the question is here on this one, will this bulb here be on or off? Sure, it'll be on, won't it? Because current can come through from the battery right to it and turn the bulb on, whereas here the current cannot get through, correct? So this bulb will be off. Now this is with a series circuit, which is so simple you won't get it on the MCAS, but you will probably get one with something a little more complicated here, and that's with a parallel circuit. And I've chosen one with 3 legs to make it fairly involved. So we have 7 switches named S1 to S7, various places. We also have 7 bulbs labeled B1 to B7. The legend is, if this sort of orange cover is on here, then the bulb is on. If it's like this without the orange, it's off. That's the way I've done things. Now the first one's easy. All the switches are closed everywhere, right? So current can flow everywhere. It can go down here to that leg, get all those guys. You can get that one and those and that one. And then this one too will come over here, and they'll join it back together and turn him on. So everyone's on because current can flow everywhere. Well, let's start opening some switches though and see what happens. Now switch 1 is open. It's easy. All bulbs are off. Why? Current comes here and it all stops dead right there, doesn't it? It can't go any further than this. It can't reach that bulb. It can't reach anybody. It stopped right there. So very obviously, if switch 1 is open, all the bulbs are off. And see they have no orange on them? Right. This one here isn't quite as obvious. We closed 1 and we opened 6. Now let's read this over here. They're all off, aren't they? The reason is that no current can return. You have to have a closed pathway. The bulb must be on a closed pathway, meaning that the current must be able to get back. So over here in the last one, well, the first one, all this current could come back this way, couldn't it? It came across here and made it back. So each light bulb was on a closed pathway, and each was on. But here, no pathways are closed because that one is open. It's at the end. So no current can return. No light bulbs are on. How about this one here, S2? That's interesting. Okay, S1, it can come through here. Current can turn right and turn these 2 on. There's a closed path right there, right? Is there a closed path involving any of these light bulbs? No, current can't get through here, can it? It can't even get to those guys. So there is no closed pathway for B2, B3, B5, and B7. They'll be off. Here's your code, open switch. Open switch. So here are the rules. For a light bulb to be on, there must be a path from the positive terminal of the battery to the bulb, current to get there. There must be a path back to the negative terminal for current to return. Here's the last thing. No fair using a wire for 2-way travel. Each section of these wires has to be a one-way street. Now, S7 down here. Again, the current can get to all these guys, right? It can get here. But can it get home? Can't get home, can it? So all these guys are off. None of them are on closed pathways. So they're all off. Well, these guys again are on because we have this open pathway. Now I want to try something a little tricky. Let's add a horizontal line between leg 1 and leg 2, right there. I'm going to add it right there, and leave S7 open. Do you think that any of these guys over here will be on now? Watch this. It's kind of tricky. Let's say it can come across here. Let's say it comes down here, goes through this guy. It comes down here now. It can't go home this way, but it could turn right. At that point, could it take a left on our new wire? Couldn't it go right there? And then could it get home? Sure could, couldn't it? So these will all be on. Most of them anyway. Here's the travel. See, up around the end, down here, up here now, and take a left. It makes its way home. So all these guys here, the only guy I won't be on is this guy here because there is no way to get home from here. I mean, the current could reach it, but he can't get home, can he? The current that gets to him. Alright, so I guess that's about it. The summary is, when you're asked on the test to do these things, here are the rules. You got to have the current get there, it's got to get back, and no fair using a section for 2-way travel. They're all one-way streets. 3 seconds.